Live. Hello. Alright. Just give me one present second. Alright. Alright. So, cool. Today we are going to be programming the Nether Star just like we have been the past few streams, but more specific, we're actually be programming today. So the past few streams we've just been sort of looking at Minecraft source code, trying to figure out what's going on. Today we are actually doing some programming. So we are trying to program the Nether biome generator today so we can predict with accuracy what each biome is in. And so there's a few parts to the puzzle. I figured out this huge trick yesterday. We're going to go more into detail about this in a second. But it allows us to cut out a huge amount of processing power that we don't need because of this one flag. So yeah, it's very nice. I've mathematically confirmed it to be true, so that's super nice. But today we are going to be programming the Nether biome generator. So how exactly does it work? Well, Minecraft has, we're going to talk about a little bit how the randomness works. So there's a random generator. There's two random generators. LCG, the legacy one used in pre 1.18 for the overworld, and this is also used for the Nether, called a linear congruential generator. It generates random numbers by using a linear mathematical equation. Then the newer one is called the Zoroshiro 128++ generator. This works by doing an XOR, then a rotate, then a shift, and then a rotate on a piece of binary. It's very fast, but the Nether hasn't been adapted to use it yet. So we have to use the LCG. This is directly copied from Mojang. Literally, I just been translating it. You see here I got this result. Here I got the same exact result. So they are exactly synchronized. So what do we have to do to actually implement this? Well, if we look at the source code, we're not going to be diving too deep into it because we actually don't need to, but we'll get a little bit of an understanding. We have the legacy random source, not that important. But if we go to random state, which is responsible for making the biomes, we can see that there's this BL flag, and this is better named to uses legacy random. Basically, if we're using legacy random, which as you can see from the JSON, the Nether is, what happens is the temperature, vegetation, and shift properties are overridden. The Nether doesn't use, you may have heard of this, but Minecraft has 7 properties to determine stuff. It's temperature, humidity, or vegetation. What's the other one? There's another one. What's after that? There's 7. But we don't need to worry about them because the Nether only uses temperature and vegetation. We can confirm this if we go to the multi-noise biome source parameter list. Down here, this is the Nether properties, right? We use temperature, vegetation, and the rest are blanked out except for the last, which is offset, which we don't need to calculate. This is a fixed value that Mojang is just tuning to get what we want. It's because it calculates the distance by using the Pythagorean distance formula. So we can artificially increase distance. So the higher the offset, the rarer the biome. And I confirmed this. The warped forest is here. It has the highest offset. And as you know, if you look up, the warped forest is the rarest biome in the Nether. So yeah. But because of this, it sets the temperature and noise instead of doing, or the humidity, instead of doing the complex density function routine, it fixes them at this. Very simple, direct values using an LCG, making it super easy for us to implement. Additionally, the shift, this is actually pretty interesting, it does use a random, but it doesn't need to because it sets it to 0. So, and I've confirmed, I recreated the normal noise class. I call it double Perlin noise. I've recreated it in Rust. 0, 0 gets you 0 out, just like you would expect. And I did use mixins to programmatically test. That is what happens, which it is, and its side effects, which they were exactly what I predicted they would be. And so what this means is the complex density function that uses the shifting, noise, and the temperature all works out to just multiply the x by 0.25, the y by 0, and the z by 0.25. That is the entire mathematical equation to calculate the temperature for it. It's super simple, but we do need to implement the create legacy nether biome function, which I currently do not have implemented. So that's what we need to do right now. And this is basically just using the linear congruential generator instead of the Zoroashiro 128 generator. So it's basically just a different way of getting random numbers. And it is hot as hell in here. I'm trying on my AC. Okay, so let's begin. So, but this stream, like, I already have an understanding of how this works. I'm very confident I can get the biome done by the end of the stream. So we just have to implement this. So we're going to go down. So there's 3 different levels to it. There's the Perlin noise sampler, or improved noise as it's called in the Mojang mappings. Then Perlin noise, then double Perlin noise sampler, or normalized. So it just goes up like this. And so we need to implement the legacy function at Perlin noise improved noise, then at Perlin noise, and then at improved noise. So we need to go to, what was it? Was improved noise. And we need to figure out how does it handle the legacy one. Does it? It doesn't look like it does. I think maybe only Perlin noise does that. Yes. So we just have this. Yeah, we just have this flag here. So we just need to add that flag to Perlin noise. So basically this, if BL else, this whole thing, if BL else we do all of this, we need to implement that. So I'm gonna move this over to my second monitor. Fortunately, it means you won't be able to see it, but. Let's go ahead and get to work. So we're gonna go to the octave Perlin noise sampler, which is what it's called. But constructor force is the true. We actually don't need that. We need to do is modern. This is going to be a boolean that tells the computer if it's modern. Okay. So we need to check before we do the random source.fork positional. So we need to implement that in LCG. What does fork positional do? We need that from the legacy random source. Towards new legacy random source.legacy random source factory. Oh, dude, I hate object on. Next, this.next long. How do we get this.next long? Alright, and this is from, we want the density, we want it from legacy random source. This dot next long is equal to this dot next. Okay, so let's implement that. We are using long terminology. Traditionally, you would do like I64 in Rust, but we're trying to give it the benefit of the doubt. So we're going to be using the Java terminology, which is long, but in Rust, this is just an I64. Assuming 64-bit architecture, which I believe Java requires. I don't know. Okay, I equal data next. Oh, wait. Yeah, you're going to be 32. Okay, so we just do next there. Next in. apologies. Let j equal next int data as well. So these are going to get us these components. I'm going to be honest, I don't really understand what this is doing. Best part about translating code is I don't have to know what it's doing as long as it works. Or I don't have to understand how the math works. I do have to understand how the logic works. So we're going to do we're going to do a bitwise operation on 32. And we need to convert this to a long. So we're going to get all of this and do as I64. And we have to return L plus J as I64. Okay, and so this is the next long function. Now we have to go back to the legacy room. So I realize I'm saying this, but you can't see it. I understand you can't see it. I don't really want to set up both my monitors. So we need to do fork positional. Legacy random source legacy positional random factory. What do you do? With a seed. Math.get seed ijk. Okay, let's take a look. What is it actually using that we need to implement? Because I don't want to implement something if we don't have to. It's, what do they call it? Perlinoise. I'm getting used to the Mojang mappings. So we do from hash of is all we're really using. So we just need to implement from hash of string, and we need to implement that for the legacy positional random factory. So we'll do pub struct lcg pause data. I don't understand. If you're asking why it's doing this, I genuinely don't know. I'm just gonna implement it. I'm sort of doing a mix between object-oriented and procedural, but I'm sort of leaning more towards what Java's doing, even if I necessarily wouldn't do it, just because I want to maintain accuracy. So we want to do, let's do pub function init factory pause data. Again, I don't know. We need the seed, so we'll do set seed pause. We're gonna get an I64, and we're gonna say it's just gonna be that. And we're gonna return LCG pause data, and we're gonna say we want to set that. So we'll say LCG pause data, and we'll just pass C directly in. Okay, then we need to do at. So we'll do pub function random. What is it? Return new legacy random source n. Oh, so it's returning LCG data from a position. LCG data. Oh no, hold on. LCG data at. And we need IJK, and this is going to return LCG data. And so we're going to say let L equal, oh, we have math.getSeed. Alright, we need to implement this in our math library. Like, this is mainly just copying and pasting, really. Get seed, it's going to take in int I, j, and k. It's going to give us a long out. And so we're going to do let L equal I times 3. Yeah, we're gonna copy paste it. It's because it's just a big old math thing that I don't understand, and we're just gonna translate it. Translating between languages is actually pretty easy. The hardest part of this project by far isn't the translating. Like, what the hell, dude? What is this? It's just the conceptualizing what the game is trying to do, because it's such a large code base. Okay, and L, we're gonna make this L mutable. L equals L times L times, I'm pretty sure this is the Perlinoise, like, formula? potentially. It looks similar to it. I could just be completely wrong though. This L again. And we just want to return L shifted 16. And what's oh, we need to make sure that you are in I-64. Expected I-64, found I-32. Oh yeah, we need to do I. Here, I'm gonna say, do we use I ever again? We only use ear, so I'll just do as I-64. So convert it to 64 as well. What's wrong? Found it as I-64. Do you need to be okay? That satisfied you. I don't like the bitwise, the math stuff. I don't really understand how it works. I just know that it works. Luckily, the concepts are universal in pretty much every language. Okay. Back to the legacy random noise. We're going to do math helper. Or did I just call it math? Whatever. Get seed, I, J, and K, and this is going to return us an I-64. This parameter has. If this is a parameter, then give it a type. Let n equal L. What does this operator do? What is it called? What does it actually do? Manipulate state directly in a binary level. Yeah, what is it? I know it's a bitwise operation. What does it do? Exclusive OR. Returns 1 if the bits are different. Okay, so it's an exclusive OR. I don't understand how exactly. I don't have to understand how it works, is what I'm saying. This is going to take an LCG pause data, and we only need to read from it. So we'll just say pause data. It's going to be an immutable reference to LCG pause data. And we're going to say pause data.seed. Right, and we're going to return, or we want to do LCG data, where we just give it the seed directly. So we're just going to, we'll call set seed, and the seed is going to be M. And yes, there we go. And then it will do the transformations to that we need. So that's cool. We also now need to do, we actually didn't have to implement that. LCG pause at, let's separate these. No. I was going to say separate these to a different module, but I think that would probably be a lot worse. Then we need to do from hash of. So we need to do from hash pause LCG pause from hash of, and we need to get a string, and it's going to return LCG data. What is hash code? This is a Java function. Do we have that? What does hash code do? Wow, this is a big ass function. What does string.hashcode do? Alright, string. We have to implement Java's function for it. Ooh, it looks like it's programmed in C. We're looking for the hash of function. I'll put this over here. So we need to figure out how to implement the hash of function. No, it is hash code, sorry. Returns a hash code for the string. The hash code for a string is computed as... Oh, let me zoom in. Oh. We'll search for it. Here it is. So it's computed as S0, the first character, times 31 to the power of n minus 1. What is n? Where Si represents the ith character of the string, and n is the length of the string, where it indicates explanation. Okay, so to rewrite this in a sort of Rustish way, string dot, and we need the character I, where I represents the character, times 31 to the power of n, which is string dot length, minus 1, plus, and we repeat this process until we've done it to the entire string. So we need to implement that. I think it's fine to put this in. Let's put it in helper. I think helper. It makes sense for this to be in helper. So we'll do hash code, or sorry, hash code from string. So we're taking a string. Sorry. I don't code Java, like I literally have never used it before, but just like looking at it, because I've used C-based languages in the past, it just makes me want to type the type first. I do prefer Rust though. Alright, so we need to iterate through the string for each character. So we'll let length equals string dot length. And then we need to do for char in string. Is this valid syntax? String dot iter. Is there iterate through characters? There's got to be a way to do it. There has to be. Let me look this up. Rust iterate through string. Dot chars. See, I told you. Okay, so we need to do dot bytes, it looks like, because Rust and Java handle it differently. Okay. So we need to do. So this is the ith character, and we need to have the total. Let mute total. What type is this? It returns an int, so this needs to be an I32. So we say total plus equals the char byte times dot wrapping multiply 31, and we want to do dot wrapping pow. The exponent is going to be at n minus 1. So the length n is the length of this string. So it's going to be len minus 1. Oh, it goes -2, then -1. So let is len minus 1 or 2. This sounds like really bad naming, but I actually like this naming. Is no. Oh, okay. I'm gonna create a quick create nested enums. Underrated. Enum len type len minus subtraction type, or sorry, string subtype. This is going to be 1 or 2. You know, I'm now realizing we could just set this to like the actual number. Like we could just set this to 1 instead of doing whatever that was. Len minus is len minus 1 or 2. If len minus 1 or 2 equals 1, is len minus 1 or 2 equals 2. Else is len minus 1 equals 1. What is your problem? Expected I32 found U8. Dot wrapping multiplied to dot 31. Dot wrapping pound to len minus that. Okay, we need to do this whole thing as an I32. What is your problem? Expected U32 found U size. Right. We need to convert you to... No, you could just be an I32, I guess. It doesn't really matter. Expected U32 found U size. As I32? Do you work as an I32, or do you need to be a U32? Okay, we need to make you a U32 for some reason, I guess. I don't know. Make you an U32 as U32. Used binding total isn't initialized. Total used here, but it isn't initialized. Oh, we just need to set it to 0. Value assigned to total is never read. Sure, and we need to make you mutable. Right, and then we want to return total. Okay, so we need to, because it says here, look at this, n minus 2 plus all the way to n. Oh, it goes from string here to, oh, okay. So we need to do len subtractor. This equals 1. And we need to do len subtractor plus equals 1. So we need to take 31 to the power of n minus 1. And then we multiply that. So we need to put u into here. And this could be an I32. You do need to be a U8, right? Okay, let's test this out. Because I'm getting my large language model friend is telling me I'm wrong. Okay, so we're gonna go ahead and test this out. Where are you erroring? We're gonna go ahead and just create in main.rs. We're gonna create a string. It's just gonna be, we're just gonna do println, and it's going to be helper : hash code from string, and the string is going to be hello.toString. What does it give us? An error. Double noise sampler has an error. It takes 3 arguments and 2 arguments are supplied. Okay, let's just put true for both of these. We don't care about you right now. They are going to be true because they're modern. Escape true to use it as an identifier. Oh. We need to pass it in, like, not as part of the struct. It's saying whether or not it's modern. Is modern, that's also wrong. You should be is modern. What's your problem now? Where? Where's your error? Attempt to shift left by 32, which would overflow. In here. Attempting to shift left by 32 underscore I32, which would overflow. Alright, let's see what the randoms, let's see what this does here. It does I32, 32, so we have 2 ints. Then we do that L equal too long. Ah, look at this. No, wait, this is... Hold on. Let me look this up. Yeah, so we're actually doing this wrong. It isn't this. It's this. And then this, like that. Like that. Okay, we got 239. So the hashing the string gets us 239 here. If we go here and we do the same, so we'll say, I'll get rid of you. We'll say string equals hello. Is this valid syntax? Yes, it is. Then we'll do string dot hash code. Then we need to print. Well, we need to print it. So we need to do another star dot logger. No dot logger dot info. String dot hash code. And we need to do string dot value of. And this gives us 239, then we've re-implemented them both exactly the same. It definitely was not 239. It gave us this number, but... Oh, we have a hello. This needs to be lowercase. Okay, we still didn't get the same thing. This is the wrong program. $31. Okay. Let's see. Okay, we got 466. Still isn't right. Performance multiplication using 32-bit signage. So you need to be U32. Expected U8. Found U32. Right, so the multiplication is done. Okay, so we need to char byte let 32 byte 32 go char byte as I32, and then we do byte 32. So we're converting it to a 32-bit, and we're setting you as a 32. Expected I32, found U32. Okay, I32. What do we get? 99162322. What did we get here? 99162322. Everybody, we have the hash coder. Okay, cool. Wasn't that difficult, to be fair, to be frank with you. To be frank. To be completely and utterly frank. Okay, let's go back. From hash. From hash of. Where are you from? Who? Implementations, legacy, random, positional factory. Alright. So, let I equal hash. We need to do helper, on hash code from string, and we're going to pass in the string. It's going to convert it to we're going to hashify it, and we're going to and we're going to XOR it with the seed, which is actually pretty interesting. So we need the pause data, and we're going to return set seed. The seed base is going to be pause data.seed, so our seed, and we're actually going to do I. Then we're going to do this, but I is an integer. So we need to convert it to a long. So we're going to do, say, as I64. Alright, I to the power of the seed. Alright, so this is functionally equivalent. So this is from hash of, pretty much. Cool. We're here to you now. So let's go move on to the octave per noise sampler. Actually begin implementing the noise. Alright, so we need to check, is it modern, whenever we're creating it. And that happens... Oh. Okay, let's go to random, and we'll say pub enum random source. And this can either be LCG, which is going to have an LCG LCG data, or it can be Zoro, and this will have a Zoro shear. Is this correct? Is it just equals? Sorry, I'm not really used to the complex enums. Cannot find value LCG data. Well, go find it, okay? Go find it. Zoro Shiro C data. Use struct little syntax. LCG data C val. Oh, we need to actually supply it. Well, I don't know what it's going to be. It's this. So it gets in random source, just something. And we actually don't care about is modern. It just depends on what source we pass in. So we can get rid of that. So where do we actually do it? It's after we do this .noise levels. It's going to be equal to a vector of noises. Yes, this. Octave insert, we don't care. Random splitter is here. So we need to do if let, what was it? If let random source calling Zoro RNG equals RNG, then we're doing this. Lacunarity is defined. We do lacunarity stuff in persistence. Do we care to do that? After this for loop, it ends. So yeah, this is all we care about. So we just need to put all this in here. What do you use? Expected tuple structure, tuple variant, found enum, random source. If let Zoro Shiro splitter data, is this what it is? Hold on. No, hold on. I'm trying to say. Okay, let's just do match. All right. Match RNG if it's random source colon Zoro Shiro. We want to do all this. Right, so this is if it's Zoro Shiro. If it's random source, hold on. Random source. Hey baby. Wave. Okay, if it's random source colon LCG. So if it's LCG, because like I said, Minecraft uses the old LCG generator from the Nether. So if we're going to recreate the Nether, we have to use its old generator. This is going to be the LCG LCG RNG. And we are instead going to want to do a whole separate bunch of stuff. So, what whole separate bunch of stuff are we doing? Well, we're doing all of this. So, this is all the Nether. This whole scope is for pretty much the Nether. I think also the End does this. But yes, that is currently what we are going to do. We're going to do that right now, actually, at this very moment. So we need to define improved noise. An improved noise is synonymous with just raw Perlin noise. So we'll say, want to play Ocarina of Time with me in Among Us or even better? You say that every stream. Alright? No. So Perlin noise equals, what is it? Perlin noise data Perlin. Can we do Perlin sampler : in it, and you take Zoroshiro. Ooh. You should take a random source. Let's just pass in random source LCG RNG. Pass in random source : LCG RNG, and now we have to go to the Perlin sampler and make it accept it, like some bullshit. Why no? I don't play bad games. So in it, we have to accept. So the RNG needs to be a random source here. The RNG here needs to be a random source. It doesn't matter the type. Where do we calculate it? So let's just match it. So match RNG, random source, : LCG is going to equal this. And we could define these up here. So let origin X to be a double. Let origin Y, it's also going to be double. And let origin Z, it's also going to be a double. Then we could just say those equal this. Or let's say Zoroshiro first. So if we're using Zoroshiro, it's going to be this. LCG. Zoro, I think I said this. It stands for XOR, rotate. No, XOR, XOR, rotate, shift, rotate. Very fast, but the Nether, like I said, doesn't use it. Instead, the Nether still uses the old LCG, or linear congruential generator. Very fancy. We need to do next double. I love random. I love going. Why does Minecraft have so many random functions, dude? Like, come on, bro. We need to implement next double. Next double, random source. Random source. Next double. Bit random source. Alright. Okay. Pub function next double. We're going to take in the data and we're going to output a double, which is a F64. Int let we do actually need to be able to change this. Next int val, and this will be I32. We'll set this to I. Right, like that. And then we'll have another one called, this will be next, and we call next int, which doesn't take that in, it just takes in the LCG data, and this just returns next with 32 and LCG data. Okay, so that I is going to equal next. We're going to take an I is going to be 26, and we're going to pass in the, well, we'll call it LCG data for consistency. Let J equal next 27. Whoa, that's crazy. You see, I wonder what 26 and 27 mean. There's probably some logic to it, but like, it's just, there's so many just random ass numbers in the source code. Alright, so we're going to do I as F64. We're going to do a left shift by 27, and we're going to add J to it. No implementation found for F64 integer. Then we need to do U as an integer. No implementation found for F64. What? Oh, as long. It's a long, not. So as I64, and then yeah, we can just do U. Oh, you scared me for a second. This was I64 found I32 as I64. Kaboom. All right. And we just need to return L times what number? Well, it's pretty obvious. It's 1 times 110223 times E, or times E negative 16. Dude, this is like obviously, right? Obviously. Like, what else would it be? You know? Like, of course that, you know? Like, we were all thinking it's probably going to be that, right? Of course, because of course it's going to be. Oh, we need to go to the semicolon. Okay. Now, here to the Perlin noise sampler, and do this. It is a bit annoying to do these match statements everywhere, but I genuinely think it's cleaner, in my opinion. Whoa! Did not mean to do that. Perlin noise sampler. LCG, next double, mute, LCG. If I do LCG and tab, then it should. Can you just include it? There you go. Alright, I'm getting another error. Where am I getting the error from? You see, look, can you see the red squiggly line? Because I can't. There's always some red squiggly line somewhere that I can't see. Like, I feel blind. Here it is. Here it is. Next int. We have to implement another function. God, next int bounded. Come on, bro. How do we do this one, Minecraft? Riddle me this. How do we do it now? Where do we pass? We always pass it as the first one. Not really idiomatic for us, but I literally don't care is the problem. If I and %, I minus 1 equals 0, then as consequence we may okay, dude, this we're doing this. Come on, guys. Okay, let's see if we get this. It's I as F as along, so I is 64, right? Multiplied by this dot next, or sorry, next 31 right shifted to 31. Then we convert this all, the whole thing, to an int. This is so wrong. Is this correct? Okay, let's just put 3 here just to see if this is correct. I tried I64 found I32. So times this dot next 31, which is an int. So we have to do as I64 Yeah, this is the most evil thing ever. This is evil. I actually, like, this is actually in Minecraft source code. Every time you play. What the hell? Is that do while? Do while versus while do. Okay, so we just do a loop and we test after. So we'll define two values. Let j equal 0. Or let j, it's just going to be an I32. Let k, another I32. And we're going to do j equals next 31 with our data. This is true, this is true. K equals j percent sign I. Okay. So you have to do if j, that is j, I think. Yeah, minus k plus I minus 1 is less than 0. So this is the condition. Now I could just like invert the signs. My best way to do this is to just put an exclamation mark here, just to make it so simple. It's basically the same thing with the exclamation mark. It does mean it's a little bit misleading, but I think it's a lot better. So if it's not that, then we want to break the loop. And we want to return k. So we'll just do k. We'll rename I to bound here. Alright, let's go back to the Perlin noise sampler. Finally, let j I32. Let's actually have a helper function that could get no. No, we're gonna keep doing this. Maybe in the future it's fine. Match RNG. Oh, I did this. Match RNG. Random source colon LCG. And that's going to equal j equals LCG colon next int bounded, and it's going to be, the bound is going to be 256 minus I, and the LCG data is just going to be a mutable reference to it. And then next up on the list of things to do, the Zoro Shiro generator. We need to do it for it too. So mute Zoro. We need to actually do this backwards. It has it backwards. So Zoro Shiro colon. We could just actually copy this verbatim. There, get rid of you, and then say RNG. This is going to be Zoro. Why are you mutable? RNG is mutable, correct? Cannot mutate a mutable variable Zoro. Do I have to define it as mutable here? Okay, interesting. Use the move at move curves because the type which does not implement the copy trait. Okay, we want this to be a reference. Is there any way to just make it quickly make it a reference? Equals, I want this to be, hold on. I want this to be a reference, a mutable reference to LCG data. Hold on, god damn it, I hate you. Okay, match, colon, mutable reference. And this will get us what this will do what we're trying to do. And we can also get rid of these right here because they're redundant now. Okay, now we have to do the same down here. So instead of doing this, we do immutable reference to it. And we don't do you, we do this. Okay, the errors have disappeared. We have successfully done it. Next. I need another cup of coffee. I'm gonna be right back. All right. I said I wasn't gonna do this. I like was lying though, so we actually are. Hold on. Yeah. Brightness. It's me. Hello, it's me. Okay, so we actually are gonna be doing the thing I said I wasn't gonna do, where we kind of unite them. So I think that's just gonna make things a lot easier. So let's just create rand source .rs, and we'll move the enum into here. This is math. Need helper. Right, exactly. We're gonna move you into rand source, and so we'll mod it. Alright. And this is literally just gonna, so the goal of this is to unite the two. So like if a function needs to call it, it doesn't need to worry about it itself. So we could do, so we're basically just gonna copy. I'm gonna open, how do you open another? It's Control Alt. It's one of these. Shift Control L, Control H. Which I always do it on accident. Is it Control K? Then press O. How I always accidentally do this. I don't know how I managed to actually do that. It's like a complicated sequence of events. Okay, interesting. Very interesting. Okay, let's go ahead and go to the Zoroshiro one. All right. So for now, we're not going to implement things they don't share. So let's go ahead and get started. Alright, first is next double, and it's going to, of course, take in a random source. Source is going to be a mutable reference to the random source. And what we're going to do is, it's very simple, we just match. Match source, random source, colon, colon, LCG, and this is literally going to be LCG, colon, colon, next double, and the data. And then this is going to return 64 because it's a double. And it's going to be next, we're going to give it the LCG data, which is just RNG. Did I-64? No, a double is an F-64, that's right. Then we can match random source Zoroshiro. It's going to be Zoroshiro, colon, colon, next double. The data is going to be RNG as well. There we go. So this is it. This is pretty much what we're doing. We're just basically implementing it. Next, we're going to do next int. Let me just replace this with next int. Next int bounded. think that's it for now. Oh, we have an extra. Dude, I have this shit so bad. I might end the stream. Yeah, I'm gonna end the stream because I actually